All right, let's jump right into a really tough topic. I want you to imagine something. A person's heart is beating, and a machine is helping their lungs breathe. But the person, who they are, is gone. This is the incredibly complex reality of brain death, and it really pushes us to ask, what does it even mean to be alive? So today, we're going to explore exactly where that line is drawn. For most of human history, death was pretty clear-cut. But modern medicine has really blurred those lines. We now have the technology to keep a body biologically functioning long after the mind, the personality, the person, has irreversibly ceased to exist. And that brings up a huge question. If a machine is doing all the work, is that person still alive? That's the fundamental issue we're unpacking today. It used to be pretty straightforward. Doctors talked about the tripod of life. That's the brain, the heart, and the lungs. They saw them as this single connected system. If one of those three legs gave out, it was just a matter of time before the other two followed. But then, life support came along. And suddenly, we could prop up the heart and lungs, even after the brain, the third leg of that tripod, had completely and permanently failed. And that changed absolutely everything.
So you can imagine the scramble, right? This new technology created this urgent situation. Doctors, lawyers, even families were all trying to navigate this totally new territory. Coming up with a new definition for death wasn't just some philosophical debate anymore. It was a flat-out necessity. The first whispers of this started back in the late 1950s over in France. But the real game changer? That happened in 1968. An incredibly important committee at Harvard Medical School was formed. And get this, it wasn't just doctors. It also included a lawyer and a theologian, because they knew this wasn't just a medical problem, it was a human one. And they decided to tackle this massive ethical challenge head-on. What this Harvard committee came up with was, honestly, revolutionary. In this world of gray areas and ethical confusion, they created a clear, practical checklist. Finally, there was a roadmap for determining when brain death had occurred, and it brought some much-needed clarity to a very difficult situation. And these criteria were incredibly thorough. First, they said the person had to be totally unreceptive and unresponsive. No reaction to anything at all. Second, there had to be a complete lack of any movement or any attempt to breathe on their own. Third, all the basic, deep-rooted reflexes had to be gone. And then, for the final piece of objective proof, they added a confirmatory test, a flat EEG, which basically shows that the brain has gone electrically silent. As science progressed, the medical community started to zoom in on one supercritical part of the brain, the brainstem. The best way to think about the brainstem is as the body's autopilot. It's this small, tough part that connects the brain to the spinal cord, and it controls all the automatic stuff that keeps us alive. Things like breathing, our heartbeat, and our most basic reflexes. Now, this is a really important distinction because it's where a lot of confusion comes from. Let's compare a vegetative state to brainstem death. In a vegetative state, the thinking part of the brain is badly damaged, but that autopilot, the brainstem, is still working. So the body can breathe on its own, and a person can remain in that state for years. But with brainstem death, the autopilot is completely, permanently offline. The person can't breathe on their own, and without machines, the entire system would shut down in a matter of minutes. They're two very different things. So when the stakes are literally life and death, you can bet the process for certifying brain death is about as strict as it gets. It's a very careful, multi-step protocol that's designed to make sure there is absolutely zero possibility of making a mistake. So let's walk through what that actually looks like. Before any tests even begin, doctors have to get through three major hurdles. First, they have to know exactly what caused the coma and be positive that the damage is irreversible. Second, and this is crucial, they have to rule out anything that could mimic brain death, like a drug overdose or being extremely cold. And finally, this isn't a one-and-done kind of thing. A whole team of doctors has to perform the full examination not just once, but twice, with a set amount of time in between. Okay, so once all those preconditions are met, then the doctors move on to a series of specific bedside tests. They're checking for the most fundamental reflexes that are controlled by that autopilot, the brainstem. They'll shine a light in the eyes, they'll check for a blink reflex, a gag reflex, and then comes the big one, the apnea test. It's a very careful procedure to see if the body makes any attempt whatsoever to breathe on its own. If all these reflexes are gone, the diagnosis is confirmed.
Now, this whole rigorous process isn't just some internal hospital guideline. Nope. This is actually written into law in many places around the world. Legal definition is crystal clear. It mirrors the medical standard perfectly. It says brainstem death is the stage where all functions of the brainstem have permanently and irreversibly stopped. Legally speaking, there's no gray area here. At that point, the person is considered deceased. And to make absolutely 100% sure, the law demands another safeguard: a certification board. So this isn't one doctor making the call in isolation. You have to have a team, usually at least 4 doctors, including the head of the hospital, an outside specialist, a brain expert, and the patient's own doctor. And they all have to agree. It's a really crucial system of checks and balances. Which brings us to a really important question. Why? Why go through all this trouble to define this one precise moment? Well, the answer lies in something our source material calls the physiological gap. It's this tiny window in time that has truly profound implications. This quote just nails it. That physiological gap is the brief period after brain death has been declared, but while machines are still keeping the body's organs supplied with oxygen. And it's that little window of opportunity that completely revolutionized modern medicine. To really get this, it helps to think about death happening in 2 stages. First, you have what's called somatic death. That's brain death when the body as a single working organism stops. But after that, cellular death begins. A good analogy is a citywide power outage. The main power plant goes down, but for a little while, some buildings might still be running on their own backup generators. The organs are like those buildings. They don't all fail at the exact same second. And here is the profound takeaway. By defining death at the moment the brainstem fails, medicine essentially built a bridge. It created a legal and ethical pathway to retrieve healthy organs after a person has officially died, but before those organs start to deteriorate. It's an incredible concept, turning a moment of absolute tragedy into a life-saving gift for someone else. This single definition became the cornerstone of modern organ transplantation, and it has saved countless lives. So, we come back to that first question. Where is the precise line between life and death? What we've seen is that in our modern world, the answer isn't just a simple biological event anymore. It's a human one, a line drawn carefully by medicine, ethics, and law. It's a line that has done an immense amount of good, but it also forces us to wonder, as our technology keeps getting more powerful, will we someday have to pick up that pen and redraw the line all over again?